Good afternoon, this is your lovely Mr. Bryant, your little math lesson. We're starting chapter 2, which is system of equations in various forms. This first section is dealing with two equations and finding their intersection, which is solving for two equations with two unknowns. What we mean by two unknowns is, for instance, we have an x and a y. We're trying to find out what number can I put in for x here and for y here that will make this equation equal to 9. But those same two numbers will make this equation equal to 1. Now, what we want to do is let's go ahead and take this. We're going to go ahead and copy this out. And let's paste it into here. And let's see how that turned out. It turned out okay. So let's go over and look at it. So here we have 2x plus 5y equals 9. And we have x minus y equals 1. So here we have two equations. Now if we're doing this by graphing, what we'll have to do first is change these equations over. This arrow right here and this arrow right here are showing you that they converted this to y equals mx plus b form. Because once you have y equals mx plus b form, you can then graph it by hand or by using your TI-83 by putting it into the y equals button, which I'll show you in a minute. So first let's get these y's by itself. So for this first one, remember we have 2x plus 5y minus 9. And actually let's go ahead and I'm going to cut this and go back here. Let's just ignore that part. And yep, I don't want to use you right now. And let's just copy this first one. 2x plus 5y equals 9. And copy it and paste it. So it popped up down here. Let's go ahead and move that right in the center. Okay. So again, what we want to do is get the y by itself, which we know this from earlier on. So first what you can do is you always want to move the part that has the x attached, which is right here, the 2x. How do I move a positive 2x to the right side of the equal sign? Remember, here's the equal sign. This right here is the equal. So what we want to do is, it's a positive, so I want to subtract 2x from both sides of the equal sign. Now, can you take 2x from 9? Of course not, because the 9 does not have an x on it. Okay, we're going to zoom in a little more. It doesn't have the x on it. So let's write this with the negative 2x in front, and then the plus 9 right after it. Okay, what that leaves us on the left side of the equal sign is this crosses out because 2x minus 2x is 0. And it means 2x's minus 2 more x's. So you're left with 5y. Now with that said, 5y equals negative 2x plus 9. Now we're almost done. It's just a two-step equation to get the y by itself. Remember, you have a number touching a letter. 5 is touching the y. So we want to divide both sides by 5 in order to get rid of the 5 touching it. Okay, now when we divide 5 into 5, we know 5 goes into 5 one time. So we cross it out and have y is equal to negative 2 over 5x plus 9 over 5. Because the 5 has to get divided into both pieces. Up here we have, let's just control this, Mr. Bryant. So here we have the 5 needs to be divided into 2 and the 5 needs to be divided by 9. But of course you know 5 can't be divided into 2 and 5 can't be divided into 9. So we leave it as is. So the y is by itself. Alright. Now our second equation that we need to get the y by itself, we have x minus y is equal to 1. So let's go ahead and copy that. Paste in our nice little Mimeo projector. Let's go ahead and zoom out. So I can get a handle of this and put it right there next to the other one, so you can see what's the process. Now again, we have x minus y is equal to 1. This time, we're still going to start by moving the same thing first, which is the x. Now what kind of x is that? That's a positive x. Don't look right here at this negative, because this negative belongs to the y. Remember, you always look to the left of a letter or number, any term, to get the value of the term. Remember, a term is like x, or y is a term. Each piece, like 2x, 5y, and 9 are all terms. So to get rid of this x, it's a positive x, so we're going to subtract x from both sides. So minus x and minus x. Now again, you know that crosses out. So 1 cannot be 1 minus x. You can't take an x from a 1. So write it side by side with x in front, so we can get it into the y equals mx plus b form. Oops, and then plus. I'm going to make that a plus. Let me go ahead and erase this. Probably really big. There we go. So minus x, and then that becomes negative x plus 1. On the left side of the equal sign, we still have a negative y. So remember, that's like a negative 1 in front of that y, because you only have one y there. So we got to get rid of that by dividing by the negative, or negative 1, on both sides. When we do that, oops, the negatives cross out, and we're left with y is equal to, what's negative x divided by negative 1? Well, it's a negative divided by negative, so it's a positive x. And how many? Negative 1 goes into 1, negative 1 times. So we write minus 1 underneath. So y equals x minus 1, and y equals negative 2 over 5x plus 5. Okay, I'm just going to shift this over some, minimize all of this, and we're going to bring up this right here, which is our calculator. Bring this back up. No, not that one. Got a lot of work going on here. We're going to go to on y equals. Let me clear out whatever was still in here. And y1 is going to be, remember, in parentheses, negative 2x divided by 5. This is just one way to put your fraction with the x. You can also, let's back up, because usually I teach you to put the fraction in parentheses and then the x right after, plus 9 divided by 5. Then the second y, or y2, would be this one, y equals x minus 1. And you do x minus 1. It's just what's on the right side of the equal sign, because we already have the y in our calculator. So now we need to click zoom. Let's try a standard. It's always a good one, because it's from look at the window, and it's from negative 10 to 10 and negative 10 to 10. Now if the two lines cross and make an intersection, like on this graph, then we know that we have a solution. So we want to find the intersection. So we click second, trace, because we want to calculate something. We want to calculate an intersection. So click number 5. When it says the first curve, it's just telling you to choose a point on the first curve. It's already blinking on the first curve, so let's click enter. Then it'll say second curve. So let's click enter again, because we're already on the second curve. I know it doesn't look like a curve, but it is a line, which is a curve, a type of curve. It's a straight curve, if you will. Click enter, and now the calculator is going to take a guess. But we know the calculators don't really guess. They take a very accurate guess. So the intersection 2, 1. That means that if I plug 2 in for the x on either of these equations, this one or this one, and a 1 for the y on either equation, I will get the answer of 1 for the one on the right and 9 for the one on the left. And then that has solved the equation. If you graph this and you get, say you have a xy graph, and let's say you graph this and you turn out to have 2 parallel lines. Well, we know that and I know my lines are not straight lines, so But if they were parallel, that means there would be no solution. There would be no 2 points that would make both equations equivalent. So therefore, there'd be no solution. Another way is if you graph your lines and you have one line across, and then I'm going to just other line in a different color. I'll do black, but it's right on top of the other line. And what's happened there is that you have the same equation. The two lines, all x's and y's, land on both lines. So when you graph this in your TI, it'll look like you only have one graph. It will look like there's only one there. Even though you put two equations in, when you graph it, you only see one line. Alright? So with that said, that is the first example of section 1 of chapter 2. That's only the first example when we are solving by graphing. And again, like always, I thank you for listening. I know